So, microservices or microservice architecture is an approach that structures an application as a collection of services, and those which are amongst a bunch of other things independently deployable. They're generally pretty small, focused on a specific service or a task. And because they're focused on just a specific service or task, they tend to be highly maintainable and testable. And so sometimes you see these services organized around business capabilities or owned by small teams. And what microservices can allow you to do is lead to rapid, reliable delivery of large, complex applications and be able to provide a fair amount of flexibility for technical evolution. So if you need to update or bring in more up-to-date modules or libraries into your existing tech stack. But it's also worth mentioning that microservices aren't necessarily always the best or the optimal architecture for a tech stack versus, let's say a monolithic architecture. There's parallels to the debate between an agile and waterfall project management approach. And so, while we're here talking about microservices and the value that it can offer, there is a fair amount of personal research to be done when you're building your own applications to sort of see if the approach with microservices is best for your practice. I'll maybe just pass it on here to Devin to talk a little bit more about microservices.
Yeah, no, that was a super good summary, and I love this slide for communicating that. So, yeah, most of us, whenever we build our first apps, we build it kind of, we build it as one thing, and that's great. It works really well whenever your app is still pretty small and isn't doing a lot of things yet. But over time, it starts to take on more and more domains of responsibility. So when you add a new feature, it might not necessarily be exactly the same thing as before. I mean, software naturally evolves over time. So what happens is the app just it escalates, it gets larger and larger. And at some point, your teammates will start referring to it as the monolith because it does everything. And your builds start taking longer, your dev process starts taking longer, and it gets more difficult to build and deliver software as quickly as you once could. And so I like to think of microservices like this kind of architecture, which does have its own problems, but as a way to kind of go back to that, when you were first building the app, everything was small and tidy and clean. It's a way of doing that at scale. So you can build as many features as you want in these small microservice forms, and you just have one API gateway to kind of correlate them together or to access them through. And so you can do this really transparently. And so what we're going to be talking about today is how you can build your next feature in whatever app you're working on as a microservice, and Link can enable you to do that really quickly. And so I'll step back and let Harish take over again.
Cool. Thanks, Devin. So in this diagram here, we've got three different services connected, to three different databases. But these backends here can actually be either internal, or they can even be managed hosted solutions, such as a cloud solution from Amazon, or a public decentralized blockchain, or a container running both sort of the service and the hosted solution. And so sometimes you may not even actually know what the backend is. And if it's not necessarily central to you delivering value to your end users and customers, it may not even be necessary to really know the details for those hosted solutions. So with Link, currently the hosted solution is blockchain, but we like to think more broadly in terms of providing a managed hosted service that allows you to quickly build microservices without necessarily getting into the nuts and bolts and the details of what's running under the hood. And so we'll see this in our demo example here. So in past webinars, we have demoed this collectible assets app. And to visualize it from the perspective of microservices, here we've got our architecture basically broken down into an ownership service, payment service, and a service we haven't demoed yet called a comment service. And so with Link, each of these services can actually be running on a completely different hosted infrastructure. We can use 3 different blockchains, as we will in this particular case here. And it's literally plug and play between these different networks. And in general, any Ethereum compatible blockchain or network. And so we'll kind of see what this code base looks like here. But from a visual, we've effectively got our front end with our index HTML file. We've got our app complete, which then ties in with each of the ownership, each of the services that we've built out, which are then connected to their respective networks. So here's an example of how we can take an application and break it out into multiple layers that each talk to a particular network. So we also showed this slide in the last webinar here, but just to walk through again the flow for how you actually deploy and interact with an with a contract that you deploy on a blockchain. So from Link, you have the ability to create your smart contracts. You then go and identify which particular network you want to be using and deploying on. You then need to connect to that network. You need to have Link connected to that network. And the way this is done is if there's a public JSON RPC URL that you can use, so a public node, you can just use that URL. With Ethereum, a common way to do it is with third-party provider like Infura, which provides a hosted node, so you can use that URL to connect to the Ethereum mainnet along with all their test nets. And so we'll be interacting with each of these different networks, but just to highlight how we actually go about connecting with them from Link. We'll then deploy the contract to that particular network. We then label our API. We then label the consumer. So this is the client that's actually going to be using and making the calls to the API engine. And we finally have our OAuth piece here that takes the client ID and client secret, provides an access token, which is then used to interact with the APIs. And so again, this is sort of the flow as we create a new project in Link that we'll be walking through here. Okay, let's dive into the application itself and see from a microservices perspective how this collectible asset app looks like. So just want to point out our website here where you can get started. There's also a bunch of tutorials that we've built. For this particular demo, we'll be going through and using the elements of this Microservices Demo repo. So it's publicly available. If you go to GitHub Blockmason, you can download this and use it to follow along. So when you log into Link, this again is the first thing you see. This is the Link IDE. And thanks to Devin with his engineering magic, we've got a bit of a cleaner interface here where each of the projects that we build will now be visible in this first screen here. So as you can see, we've got our demo smart contract. I've also gone ahead and created and deployed a CryptoChicks token, which you can go ahead and do or create your own custom ERC20 token. We have a blog post about that, and we've taken that and deployed it on the Ethereum testnet, the Ropsten testnet. So let's go ahead and create our ownership microservice. So back in our repo here, I'm just going to go to our contracts. We'll take a look at the ownership.sol. And again, this is probably pretty familiar. It's a very simple smart contract that maps an asset to an address. And so let's go ahead and create a new project. And this is going to be a new contract that we are going to deploy. So I'm going to copy paste that in here. This is going to be our ownership contract. And taking a look again at this image here, we're actually going to deploy this contract onto GoChain. And we'll talk a little bit towards the end about why we make that decision between chains. But for now, we'll go ahead and use that public blockchain. And the way we connect to it, if you go to the GoChain docs, is there's these two URLs here, these network RPC URLs I had mentioned before. And this is how we actually get linked to connect to these to the GoChain testnet or mainnet. So we're going to be using this URL to connect with the GoChain testnet. And remember, when you're using the public blockchains, you do need to seed your link account with some either test Ether or test Go, depending on the network that you're using. So I've already gone ahead and seeded my wallet address, which you can find by clicking on this little wallet icon here. I've seeded it with some test to Go and some test Ether. So I'm just going to save the contract. Okay, so we're going to use that. We're going to use our default Ethereum account that comes with Link. And now we're actually going to create our label for the GoChain testnet. And this is going to be our GoChain testnet connector. And here's where we paste in the URL that we get from the documentation for both the mainnet and the testnet. So let's copy the testnet URL and we'll paste that here. Just make sure we're working with the right network here. So let's save that. And we are going to call this our ownership GoChain deployment. So if you have a contract that's already deployed on, let's say, GoChain or Ethereum or whatever network you're connecting to, you can actually take the existing address, paste it in here, and be able to connect with an existing deployment. In this case here, this is going to be a new deployment, so we're going to leave that blank. So you've got our account, our contract, our network. This looks good. Let's save that. And now we're going to be asked if we want to perform this deployment. So let's go ahead and deploy that. Generally, if you're doing this with the Ethereum Ropsten network, this might take anywhere from 30 seconds. It could take almost up to a minute. We do this with our the Link private network because it's sort of an optimized and a local network here. It runs pretty quickly. GoChain's also pretty quick. So we're going to call this our ownership GoChain API. So this is the label for the APIs. And the consumer is going to be, again, sort of the front end that's actually going to be using the APIs. And so let's call this the Collectible Assets App. We'll automatically get a client secret assigned to us. And there we go. So here's our ownership contract that we've just deployed. And here are our corresponding APIs to set the owner, to get the owner, and to get the authority. And again, these correspond to the set owner function we've got here, a public getter for the owner of, and the public authority address as well. We also now have this little gear icon here, and clicking on that drops at the bottom of the screen the client ID and this client secret that's required to be able to authenticate with Link, and in particular to be able to authenticate and use this set of APIs here. And you'll notice that every time you create a new project, you'll have your unique set of client IDs and client secret to use to access that particular set of APIs. So let's take a look at what the code actually looks like. We've deployed our ownership contract. Let's take a look at our code base here and what the ownership services code looks like. So here's our ownership services code. Everything here is done in JavaScript. And you can see the way we've got this structured. We're pulling in using the Blockmason Link SDK. So we're pulling in this Link object. Here we're going to pass in our client secret and our client ID. It's good practice not to paste those values directly into the front end. So we're actually using this .env file, and we'll paste in our client ID and client secret here in just a second. But this is where it gets pulled in. And then we've got our get owner, get authority, set owner function. And so it's a relatively small piece of code. It's a specific service that does, provides one particular function, which is setting the owner of an asset and then being able to retrieve the owner of that asset. So let's go back to Link. We'll copy our client ID. And then in our env file here, this is for GoChain. So we're going to paste that here and copy our secret, and that will go here. Okay, great. So we've got our ownership contract that's in place. We've already, as mentioned, we've already deployed this CryptoChicks token, this custom ERC20 token onto the Ethereum Robston network. And we can see where that's been deployed. If you click on this icon here for the Ethereum contracts deployment, we see the addresses for where the deployment lives. So if I take that address, go to the Robston Explorer, in fact, I'm already here, and we can see this is our CryptoChicks token that was deployed earlier today. And in terms of the function or the microservice that we're using for this particular contract, let's take a look at our code base here. So we've got a payment service that we've built, and the payment service is actually even simpler. All it does, it takes in the receiver for the payment, the amount, and then makes a post request to this endpoint here, which is the transfer endpoint. And we can see, we go back to our CryptoChicks contract here and our APIs. We're just calling, there's obviously a handful of different endpoints here for this particular smart contract, but we're calling this particular endpoint here. So we need to pass it the address and the value. And that's what we're going to be executing in this code here. So that's our payment microservice operating with the Ethereum Robston testnet. Finally, we've got our comments, and our comments. This is a new contract that we built. Pretty simple. It's used in one of our blog posts on plugging in blockchain to a social network type of application. And all this is going to allow us to do is for a particular asset to be able to provide a comment about it. And there's this post comment here function, which then actually triggers it to be recorded as an event on the blockchain. So we're going to actually take this particular contract, we're going to deploy it on the Link private network, and then we're going to plug it into our application as part of the comment service. So just going to copy that code there. We're going to create a new project. This is going to be our comments. Okay, so let's save that. Okay, we're going to use the default Ethereum account again. We're going to use the default network, and this is the Link private network that comes standard as part of Link. It runs under the hood. We're going to use the default network connector, and we're going to call this the comments Link private network deployment. Okay, that looks good. And let's hit deploy. Okay, so our contract's being deployed to the Link private network here. And this is going to be our comments Link private network API. Okay, and again, our consumer is going to be, we'll call this our collectible assets app. We'll get our OAuth client here set up, and here's our comments smart contract. Here are APIs, and here is our client ID and our client secret that we're gonna use. And so let's take a look at what our common service actually looks like. So here we're using the Blockmason Link SDK. We're pulling in the link object, passing in the client ID and client secret. And we've got the ability to post comments. We've got the ability to get the comments as well as print them on our front end display. So relatively simple JavaScript file here for our comment service. And so how this is all tied in is we've got this app complete file here. And so here we're just pulling in each of our services, and we'll display all our assets. In the past, they've been known as stamps, which is why it's labeled as that. And then every time that we want to set ownership, we call the ownership service. When we want to make a transfer payment, we've got the payment service. And when we want to post comment, we call the comment service. So everything being done here is done by calling the respective functions for the appropriate service that we want to use. And that helps keep this code base relatively nice and clean. You'll also notice that we haven't had to make use of Web3.js or any of those complex libraries, even though we're dealing with blockchain on the back end here. All that complexity is abstracted away, and we're able to just code as we would to build any sort of JavaScript application here. So before I forget, let's just add our credentials here into our .env file to get this all plugged up as expected. So we've got our link private network. We need our client ID. So I'll copy that for our comments service. And let's copy our client secret. Okay, so we've got the comment service tied in with the link private network. We've got the payment service tied in with the Ethereum Robinson network. And we've got our ownership records tied in with the GoChain testnet here. Great. So let's actually run this and see what this looks like on the front end. So this is configured with Parcel, and we've got an alias here to just simply call npm start. And we'll just get this fired up in just a second. And so to quickly talk about a little bit while this is loading up here, why we might want to be using 3 different networks here. If let's say we've got 1,000 different assets that we want to record ownership of, to do this using, let's say, the Ethereum testnet could be pretty expensive. We also know that the Ethereum network can be a bit slow, and so to use that particular blockchain may not be the most performant backend for an application like this. Whereas with GoChain, it's much more performant, as well as the gas costs are significantly less. And so if we're recording such a large number of ownership records, we might want to be using a hosted solution like the GoChain testnet. The payments, Ethereum's got a pretty good ecosystem of different tools like the Explorer that we saw, as well as a bunch of other tools. So in terms of maybe transparency or being able to use some of these tools in the ecosystem, we'll want to use this particular testnet for payments. And then finally for comments, we may not know what the value in those comments are, but we want to store them for now. Being able to use something relatively quick like the link private network that comes as part of the application, that might be a suitable backend for that particular service. So that's just just some logic that we're putting forth here. but you may have your own reasons for picking and choosing your particular network, depending on what your benefits and use cases are. So we've got this this running now. Let's take a quick look. Okay, so here are our digital paintings as our asset. We see that we've got a value for each of these in our custom CryptoChicks tokens. So even though we don't need to use MetaMask, I'm just going to use some of the wallet addresses for MetaMask just to be able to see those transfers actually taking place. All right, so I'm just going to copy this account here. And let's see if we can assign ownership for this particular asset here. So again, this one's being recorded on GoChain here. We see that that just got processed. There's the owner. I can even make a comment here. Okay, great. And so again, this is sort of configured, you know, assuming that there is some user here, you could tie this in with sort of a conventional login and user account flow into your front-end application. And now if I want to, so let's just take a look right now. This particular account has got no CCT tokens. So what I'm going to do here is let's just take another account. This is account 2. This is going to be the new owner of it. So we should expect this, the existing owner here to have received some payment, and we'll see that this payment actually gets triggered. Okay, looks like this just updated. We've got a new owner now. And if we take a look at our account 3, that was the existing owner. It might just take a second for this to update here. That's the thing when we've noticed when we're using the Ethereum testnet, it sometimes takes up to 20 to 30 seconds for it to actually get reflected in our tools here. There we go. So we see that 5 actually got transferred here because I'm actually using a conversion behind the scenes. So 5 tokens were actually transferred here. But yeah, it looks like the payment went through. We see the ownership being recorded, as well as the comments that we are putting forth here. So 3 different services, 3 different networks, all tied in under one single application here. So again, being able to use microservices allows us to take advantage of relatively small, very modular code. And you know, this code could be used for a host of different applications, not just the one that we're looking at here, because it is so generic. The same goes with our payment service, and the same goes with our comment service. So by being able to take an application like this, break it down into these individual microservices, we create much more reliable and robust code that can be used across different applications in sort of a manner that allows us to maintain and adapt this code as we go forward. Okay, I think that's most of what I wanted to cover here. Let me just go back to our presentation. Yeah, let's see if there was anything else we wanted to talk about. Yeah, so that's the demo. And at this point, let's open it up for questions. I know that we kind of covered some of this stuff a little bit quickly, but happy to try to address any concerns or questions you may have.
So there's like we've got one question here, Harish. Hello.
Hi. Go ahead.
Hi, hi, can you hear me? Hey, I just have kind of a quick question. Could you maybe speak to some of the applications that might lead to regarding, financial services or anything kind of outside of this demo that that has kind of been the work or that need to be developed for this type of use of the API and building out with the platform in this way? I know it's kind of a vague question, but I'm just kind of pointing at other market applications or some of the use cases and even kind of key limitations to keep in mind for other applications.
So you did cut out a little bit there. If I understand correctly, maybe you wanted me to talk a little bit about some of the applications, perhaps in the financial sector or otherwise, for a tool like this. Is that correct? Sorry, I did not catch any of that.
Hello?
Yeah, go ahead.
Yeah. So I'm sorry. I'm sorry. That was correct. Your summary was correct.
Okay, I think there's a there's a little bit of a delay here. Okay, so yeah, happy to talk a little bit about that. Just curious, Devin, did you have any initial thoughts on sort of the use cases?
I mean, generally speaking, Link is not so much for the payments side of things, because this, what you really want with users that are actually going to be paying people is direct control of their wallet. Like, those users need to have direct control of their wallets to send funds. What we saw today with Link is the Link custodial wallet was transferring the funds to the target. So it does, the rabbit hole does go pretty deep when it comes to payment systems and using something like Link. It is possible, but it's not optimal. Link is, with microservices in general and using Link, it's more for, feature development and, different slices of the product. And payments is one of those things that you could do. But in terms of like supporting that specifically, there are some dragons.
Okay, we've got a question here posted in the group chat on going over the code for the comments and payments. Krishan, was there anything specifically you want me to take a look at in those files?
Hello, yes, can you hear me?
Yes.
Yes. It's just that I kind of came a little late, so I was wondering if you could just briefly go over how the functions for the code work and just a general gist of how do you go about making it.
Okay, I can just kind of reiterate the process here. So what we did for both the payments and comments service here, we started in a Link where we've got our comments contract and our token contract. So these contracts sort of define the API endpoints that we will have access to. So this is a fairly standard token contract here, takes into account the safe math type of elements. But here are the API endpoints that we have access to. And so we were calling this transfer endpoint, which is a post request, and requires us to pass an address and a value. And this gear icon here gives us the client ID and the client secret that we need to use to authenticate with Link to be able to access any of these API endpoints for the CryptoChicks token contract. So that's what we have in our microservices file here. So we've got our client ID and client secret that we're pulling in. We've got the receiver, which is the address that we want to transfer the funds to. And we've got the amount, the value that we're passing in here. And then we're simply making the post call to this transfer endpoint. And it's very similar with the comment service. So here's our comments contract, where we've got the ability to post a comment and get all the comments as events. And what we did in our code is we simply make, in our post comment request, we get the text from the comments field, and then we make a call to the comments microservice post to the post comment endpoint. And it's the same when we get all the comments by calling the comment service slash events slash comment.
Okay, gotcha. Thanks.
No problem. What does a conversion service look like in the back end? Sorry, I did kind of glance over that relatively quickly. I mean, all it really is I was just using this token conversion rate. So, for example, what you see here on the front end, this actually gets divided by 5 and then transferred. And what I actually wanted to do was to show you what a front end would look like if it was just like any regular e-commerce website. So a better example of this is if I go to my index.html, and instead of this being CryptoChicks token, this is something like, you know, USD, for example. And so the front end now looks like any other e-commerce website. Behind the scenes, this amount gets converted into crypto using the conversion factor that I've got here. And then the payment gets done in the actual token to the owner. So it was just a kind of showing that the front end doesn't have to look like a crypto transfer, a crypto token, or anything like that. It can look like any other e-commerce site with a fiat type of value. Do we have any other questions? Anton, do you want to go ahead and ask your question? I see you got your hand raised here.
Yeah, it was interesting presentation. Unfortunately, I came a bit late, so I have these 2 questions. So first is, can we use Solidity script to call a library like OpenZeppelin? That's the first question. And then the second question is, can we use the import command in Solidity to Blockmason? So that's these 2 questions. Thank you.
Devin, do you want to tackle that one?
There we go. I struggled to find that unmute button. I don't know why. So let's see here. So what was I can handle the first question if you could just like repeat the summary of that one.
Anton, you were asking about being able to connect or import OpenZeppelin contracts. Was that?
Yeah.
Sweet. Okay, thank you. I heard most of it, but I want to make sure. Yeah. So everything that that you need in order to, you know, for that contract to work needs to be in that IDE, like as a single quote unquote file. So if you have like require statements or different modules that you're pulling in, you'll need to flatten those out before you can use them in Link. There's no sort of import functionality. Oh yeah, and I see Devonta is asking or noting that same thing. No, there's no import statements in Link because there's no file system there. It's just every service is just a single file.
There was a question about having the video posted. Yes, so this is being recorded, and we will make this this available in our developer channel, our Slack channel, and I think Clayton will paste in the URL to be able to join our developer community.